Okay. So probability is the study of chance. We looked at this the other day. You need to know these words. A trial is an experiment, like throwing a dice. Outcome is a possible result of a trial. So when you throw all of those, when you throw the dice, what are the things that you can get? 1, 2, 3, 4, 5. You can get 6 on the dice, yeah? So here you are. So we can use a tree diagram to show the possible outcomes when a 6-sided dice is rolled. Yeah, now that's too much. We won't be doing 6, okay? Right. Okay, for 2 events, combined events, you draw the lines, the branches of the tree. Yeah, you draw the branches of the tree, you put the head and the tail or whatever thing you are doing. This looks like a coin one. Yeah, the coin experiment for head and tail. And when you throw the coin the first time, you can get head or tail. And when you throw it the second time, this is the second set of branches that comes up, yeah? You can have head, either head or tail, or either head or tail again, yeah? So I'm just going to explain all of those now on my whiteboard for you guys, yeah? I'm just going to explain all of these now to you guys on my whiteboard. Give me a second so that I tell you what you need to write and what you need to not bother with. Okay. Okay. So I'm going to say sampling with replacement. And we're looking at probability tree diagrams. Okay. So they use, on my math, they use the example of a coin, maybe for heads and tails, yeah? But let's say you have a bag. This is your bag. I'm going to draw the bag or purse. And this bag contains 3 red balls. 1, 2, 3 red balls. And 5 blue balls. 1, 2, 3, 4, 5. Now, to be able to represent this information on a probability tree diagram, yeah. So let's say you put your hand in the bag and selected one ball at random. Yeah, you put the ball back in, that's the replacing. You replace the ball and then you took another ball out again. Yeah, so this is how we're going to represent this now on a tree diagram. So this is the first time that you put your hands in to get a ball. Yeah, you could have a red ball or you could have a blue ball for the first time. And when you put whatever ball you took in, yeah, then you select another ball, then you could have a red ball or a blue ball again, and you could have a red ball or a blue ball again. Yeah, so if you selected red the first time, it may be that you selected red again the second time. If you selected red the first time, it may be that you selected blue the second time. Yeah, blue the first time and red the second time, blue the first time and blue the second time. So what you have at the end of your trees would be, for this branch, this one going this way, it will be red and red. This would be red and blue. This will be blue and red. This will be blue and blue. Yeah. Now let me put some numbers in for you so that you see them. Yeah. So for the first time that you went into the bag to take a ball, you would have 3 out of 8. I told you that you always calculate the total first. So the total here is 8 beads altogether, and 3 beads out of 8 represents the probability of the red balls in here. And then for the blue balls is 5 out of 8. Because you replaced it, the number of balls inside of the bag did not change. So nothing will be affected in the second set of branches. Yeah. So the second set of branches will still be 3 out of 8, 5 out of 8, 3 out of 8, and 5 out of 8. Okay. So that's how you draw the tree. Okay, so make sure that you've drawn that tree and that you can draw it. Okay, make sure that you draw the tree and that you can draw it properly. And then we need to know how to get some information now from our tree. Yeah, once you've drawn the tree and you can draw it, you know how to draw it, then we need to know how to get some information from our tree. So you need to work out what is the probability. Your question might ask you, let me make this smaller. The question might ask you, what is the probability yeah, a red and a red, yeah, probability of choosing a red and a red. Remember when we were talking about the and rule the other day, yeah, we were talking about the and rule, and we said the multiplication rule, yeah, is the same thing as the multiplication rule. And when it says in the question, probability of this and this, it means that you have to multiply, yeah. So probability of getting a red and a red would be, if you follow down your tree from the first red to the second red, then that would be you timesing everything on that line. So that will be 3/8 times 3/8. Please put that into your calculator and let's get some answers. Okay. 9/64. Can that be simplified in any way? It's okay, we can leave it like that. Okay, well done. So that's in a simplified state. Okay, what about the probability of choosing a red and a blue? We need to write everything out. I need you guys to write all of the ends here, the red and the blue. Excellent. Well done. So you need to work them all out. Yeah, 3/8 times 5/8. And then 5/8 times 3/8. Then 5/8 times 5/8. Sally, you need to put it in your calculator and times them, okay? You need to put them into your calculator and multiply them out. This should give you 15/64 and 15/64 and 25/64. Now, sometimes, so hang on a minute. Sometimes the question might be different. It might ask you, what is the probability of getting the same color? Yeah? So the probability of getting the same color is you can get red and red, red and red, or blue and blue, okay? So red and red is 3/8 times 3/8. Or you're using the or rule. This time you have to add, okay? Or 5/8 times 5/8 for blue and blue. So now you need to put this into your calculator to be able to work out question 2. Probability that they are the same color is red and red or blue and blue. (17/32). Well done. Well done, guys. Now, question 3, it may say something like, what is the probability what is the probability of getting a blue in the second draw? Yeah. So the first time you put your hand in and drew out a ball, yeah, you got maybe red or you got blue. But the second time you got blue, what's the probability of getting blue the second time? So the only time you got blue the second time, the only times you got blue the second time, undo, redo. What's wrong with this thing? Sorry. I have to choose a color that you guys can see. You got blue here in the second row, and you got blue here in the second row. Yeah, so you have to follow it. So it's going to be red and blue, or blue and blue. Yeah, so see whether you can work those two out and let me know what the answer is. This and this, or this and that. Yeah, 5/4. I think you should check your answer because probability is not usually more than 1, and 5/4 is more than 1, obviously. So check it again for me, Abra. 15/64. We'll see now. So red and blue is 15/64. You got it there. Plus blue and blue is 25/64. You got it here. Yeah. If you want to write them all out, you can write them all out, but you already got them out here. So red and blue is 15/64, and blue is 25/64. And that's equal to what? Five over 8. Well done. Okay. I'll see if I have a nice one on my PowerPoint for you guys, okay? The one on my mouse is not so great. Okay. Okay, so we've done all these parts. The first choice and the second choice, we know how to do it. Are you sure we can see this? Maybe I will download this PowerPoint. Then we can see it. I'm sorry, guys. I have to download it. I put this in my computer. Otherwise, we will not be able to do it. The animations are not working. Yeah, but the animations are not working. I know because I've used them a lot. So I know what is meant to be doing and what is not doing. New share. PowerPoint. Share. Okay. So enable editing. And put the presentation on. All the answers are there. This is so annoying. I want you guys to do 1 or 2 for me, and it's just putting everything out. Okay. Now this is too much. I just want, okay, no, what I'm going to do is I'm going to put the question on my whiteboard and get you guys to do it for me. Because otherwise, you guys are going to, you're not going to learn anything. Okay. Okay, let me give you 1 to 2, okay? Clear all my drawings. Rebecca has 9 colored, a bag contains 9 colored beads. Okay, a bag contains 9 colored beads. Let's start. So write my question down. Four of the beads are black and the rest are green. Draw a tree diagram to represent the data. Right, hang on a minute. Did she say Rebecca? Rebecca picks a bead at random from the bag, replaces it, and then picks another bead. Represent the information on a tree diagram. That's the first thing you have to do. Put it on a tree diagram, number 1. Then you also have to calculate the probability that she chooses 2 green beads and a black bead followed by a green bead. Okay. Okay, guys, you got your questions. Okay? You got your questions, so you can make a start. Okay? A bag contains 9 colored beads. Those are, let me make a little sketch for you guys. I'm going to draw the bag. I'm not good at drawing bags. Okay? It contains 9 colored beads. There's 4 green beads. So green. 1, 2, 3, 4. And the rest are black. So put the information on a tree diagram and then find the probability that she chooses 2 green beads and a black bead followed by a green bead. Oh. Okay, good, good. I'm seeing some answers already. Good. We'll see now. We'll see now. Have we finished? Okay, so I'm going to show you the PowerPoint now. I'm going to show you what you've done. New share. Let's have a look at the PowerPoint. Where's the one we were working on? Was it this one? Or this one? Yeah, it was this one. So you can see, yeah? Check if your answers are correct, okay? 2 green beads is, probability of 2 green beads is green and green, yeah? 25/81. And the probability of a black bead followed by a green bead is 20/81. Okay, well done. Well done, guys. But what about the probability of the same color? Having the same color? 6/9. Yeah, that's fine. It's okay. I've seen it. What about the probability of having the same color? Have a go at same color for me. You know how to do it, don't you? We did it on the first example I did for you. If I say, what's the probability that he chose, the first color he chose was this, but the second color was that. Have a go at probability of the same color. Yeah, well done, Abra. Okay, because the same color would be black and black, which is 16 over 81. Add green and green, which is 25 over 81. So that will be 41. Is it up to 41? Yes, over 81. And it may say different colors. If it's different colors too, you have to do black and green and black. Yeah. What about the probability that it is not green? Probability that it is not green. The probability that it is not green, not choosing green at all. It's only one situation that you get not green. Yeah. It's black and black. So that will be what? 16 over 81. Well done. Okay. This is such a shame that it's showing everything. None of the animations working. Okay, so the other type that we have to look at is the one sampling with replacement, okay? Sampling with replacement. So I'm just going to write out this question so that we can look at it on my whiteboard, yeah, together, and I can explain it to you. Okay, so Lucy has a box of 30 chocolates. It's a box of 30 chocolates. 18 of them are milk chocolates. And the rest are dark chocolates, so that's 12. She takes a chocolate at random from the box and eats it. Then she chooses a second chocolate. Take a screenshot for me, guys, please. We're going to do it on my whiteboard now, yeah? That's fine, okay? I will be off around 3:30 myself. Yeah. That's okay. Draw a tree diagram to show all the possible outcomes. So we can we're going to draw the tree diagram, question 1. Question 2 is probability of 2 milk chocolates. And question 3, probability of a dark chocolate and a milk chocolate. Okay, let's have a look. So we have to start the branches, yeah? So we have total is 30 chocolates. So the first one is milk chocolates and dark chocolates. White chocolate and dark chocolate. Okay, then we have a second row of milk chocolates and dark chocolates. Then we have another branch of milk and dark chocolate. Oh, we'll see now. Okay, so here you have 18 over 30, and here you should have 12 over 30. And on the second one, assuming that milk chocolate was chosen first because it was taken without replacements. Yeah, if you look at the picture that you took on your phone, it was taken without replacement. It was taken, looked, and put to the side. Then, assuming the milk was chosen, then the milk is not there. One milk is off, so it will be 17/29. Yeah. But if the milk was not chosen, then if the milk was chosen, but the dark chocolate will still be 12/29. Yeah. And then if the dark chocolate was chosen, yeah, then the dark chocolate would have become 11/29, and the milk chocolate will still be 18/29. People get this mixed up, so make sure that you understand it. Let me write this properly. I was trying to make space and I ended up writing it funny. Okay, so now you can work the other questions. You've done the tree. You have to read the question. Make sure that the question is asking you, read the keywords with replacements. Okay, I'm going to show you a few of them on WJAC question bank now so that you can familiarize yourself with them. Okay, how the questions are worded. Now we've drawn the tree. That's the first part of the question. Okay, and it says 2 milk chocolates. So milk and milk would be 18/30 times 17/29. So let's see. I think it's Maha who somebody put answer in the 306/870. I think this can come down to 51/845. All right. And the next question there was probability of a dark chocolate and a milk chocolate. So dark and milk would be 12/30 times 18/29, which is equal to what? 36/145. Okay, guys. So let's look for one that you can do. I've been trying to get you one to do, but everywhere I go, it's not working. The animations or my mouse didn't work. My PowerPoint didn't have the things working. So I'm going to check another place where I get questions from. Stop share. Make sure you've written everything down. I'll take a screenshot. 5, 4, 3, 2, 1. Okay, I think we should get some now. What's on this one? So that's a nice one. Can you complete the tree for me? Mm. Okay. So noisy. Mm. Okay, have we finished? When you finish, say finish so that we can put the answers in. What are we going to have here? Okay, let me put some letters in so you can put them in the chat for me. What is A going to be? What is B going to be? C and D. Remember, the question says they are independent events, yeah? They are not dependent on each other, yeah? The probability that she wears a hat on a given day is 0.6. The probability that she does not wear is 0.2. So they are not, it's almost like saying without with replacements, yeah. So they're independent of each other. Yeah. A is 0.6. Is it 0.6 on A? If this is 0.6, yeah. If this is 0.6, what's this one going to be? Mind you, the total probability is always equal to 1. Yeah, total is always equal to 1. So if this is 0.6, this branch, the total of each branch is equal to 1, yeah? So this branch must be equal to 1, and this must be equal to 1. What's going to be on A? 0.4. Well done, now you got it. Yeah. So A is 0.4, and what is going to be on B then? I don't know. Why do you think it would be 0.8? They all have to add to 1. She does not wear glove is 0.2. She does not wear gloves. D should be 0.2 as well if this one is 0.2. Yeah. And this B and C should carry the same weight. So what are B and C going to be then? Yeah, but now you have to split it amongst the two of them. Yeah. So this is going to be what? 0.3 and 0.3. Are we right or wrong? Should we have a look to see whether we are right or wrong? Fingers crossed we are right, okay? Right, let's see. Oh, right. Yeah, that's right. Okay. Yeah. Okay, so everything here should be 0.8 on this side, but you have to split it. You have to split it. Okay. Let's have a look at another one. I'm trying to find one. All of them are the same that you have to complete all this. Hmm. Let me find some foundation maths ones. Maybe these ones are too. I put them on the higher ones. Let's have a look. Does it change? I can't find my chart. Yeah, you can. See you soon, Rakan. This is difficult. No, I'm going to stop because I can't find any good questions. I'm just going to use, I think they must have some questions in the course handbook. So I'm going to check the course handbook. Shame my PowerPoint isn't working properly. Okay. Okay, let me give you guys a question. Stop share. Whiteboard, share, clear all my drawings. Now this is from the course handbook, okay? A bag contains 10 marbles, of which 2 are red and 8 are black. Another bag contains 12 marbles, of which 4 are red and 8 are black. A ball is from marbles to balls. A marble, even they made a mistake in the book. A marble is drawn at random from each bag. Question A, draw a tree diagram to represent the data. Question B, find the probability that both are red, both are black, one black and one red. At least, that's the question I was looking for everywhere. At least one red. Okay, guys, quickly, when you finish this one, we will start to do some marking now, okay? And I'll put off the YouTube. Oh, you wanted us to do it together? Okay. So it's the same thing we've been doing now. This one contains 10 marbles. So 2 are red. So this is red and what? Black. So this will be 2 over 10. and 8/10. Yeah. And the second bag contains 12. Red, black, red, black. Okay. It says they are independent. Okay, so if there are two different bags, then they are independent. What happens in one bag does not affect the other bag. Yeah. So this would be 4/12 and 8/12. 4/12 and 8/12. Abra, are you okay with that now? Then now you can find the rest, okay? That's okay, Rakan. It's all right. That's fine. Okay, we'll see now. Okay. Red and red. Let's see. Question 1, red and red is equal to 2 over 10 times 4 over 10, which is what? 8 over 100. What did we get? Oh goodness, it's so loud. Yeah. Maha,
12.
Maha, you got it right. 0.08 for the first one. 8 over 100. It's what? Let me see. Yeah, if you got 2 over 25, I'm going to accept that as well. They're all fine, okay? They're all the same thing. All right, how about the black and black then? Oh, Abra, he might be right. When Abra is quiet, I'm worried because she will just be like, okay, let me see where they're going with this problem. I see a problem. No, nope, nope. I've seen a problem with the calculations. We missed something here. This should be 12. And this should be 120. Oh, sorry, Maha. You were close, but not quite. It's 1 over 15. Who got it right? Ah. Okay. All right then. And black would be 8 over 10 times 8 over 12, which is what? 64 over 120. How do we simplify that? What goes into that now? 8 over 15 for the second one. Yeah. It's good. It's good. Okay. One black and one red. Ah. So that's a combined one. So if you have red and you can have red and black plus black and red. Okay. Red and black is here 2 over 10 times 8 over 12. Black and red is here 8 over 10 times 4 over 12. Okay, so let's do that. This is what? 16 over 120. And this is 32 over 120. So we can write them here. Which is equal to what? 48 over 120. That definitely goes into that. 2/5. Okay, this is question 3. Okay, so to have at least one red is this one. You can have red and red. You can have blue and red. You can have red and blue, blue and red, red and red, yeah? So the only one that does not have red and red in it is blue and blue. So to have at least one red, you can either add all these ones up, or you can do 1 minus blue and blue, okay? Because all of them equal to 1, yeah? So if you subtract this one from it, then you will get all the rest of them. Do you understand? So 1 minus 8 over 15 is equal to what? 7 over 15. That's it. Okay, guys. Oh. I'll be in the background doing some marking, okay? At 3:30, I'm going to pick my daughter from school. So I will be back at 4, okay? But I'm here right now, and I will be here until 3. When you're ready to go for your break at 1:15, you can quietly go for your break. I will be here till 3. All right? If you want to leave yourself on and go for your break, you can go for your break, because I won't be teaching. I'm going to be marking. All right, guys?